Here's sample problem 5.9. Given the following information, calculate the standard enthalpy of formation of acetylene, C2H2, from its constituent elements. Carbon in the form of graphite plus O2 gives you CO2. H2 plus 1/2 O2 gives you H2O liquid. And 2C2H2 plus 5O2 gives you 4CO2 plus 2H2O with given delta H values, heats of reaction. Okay? So the key to this one is to note that they want the standard enthalpy of formation for C2H2. So let's remind ourselves how that works. The standard heat of formation, so notice, oh, they said enthalpy, but I'm going to call it heat of formation. Delta H of formation with the degree sign. That idea is generally what elements do you need to make a mole of the substance you're interested in the state they tell you. They actually, what's interesting is they don't tell you that acetylene is a gas, but if you look its value up, you'll see that it is a gas. Okay, so we want to make it from its constituent elements, meaning C2H2 has carbon and it has hydrogen. So C and H. But be careful, the standard form for hydrogen, at least at room temperature, is a gas. So it's H2 gas. And for carbon, it's a solid, or it's graphite. I'll put S for solid, but it's really graphite. Graphite is a solid. But we need 2 carbons to balance it, right? We have 2 on the right side, so we need 2 over here on the left. Okay. Now, let's see how we're going to get that particular equation from those 3 equations that are given, right? The 3 equations have graphite, hydrogen, oxygen, and then acetylene. So I'm going to use the same approach I used in 5.8. I'm going to first try to get 2 moles of carbon on the left side. So I look for the equation that has carbon, and that's equation 1, and it has 1 mole of carbon on the reactant side. So I want 2 moles. So I'm going to take the equation 1, and I'm going to multiply it by 2. So I'm going to write 2 carbons plus 2 O2s gives me 2 CO2s. And again, remember, if you multiply an equation by 2, you got to multiply delta H by 2. So delta H would be 2 times negative 393.5, which is negative 787. Okay, I multiplied the negative 393.5 times 2. Hopefully I got that right, negative 787. I also want to have 1 mole of H2. There's only one equation in the 3 that has H2, and it's the second one, and it's a mole, and it's on the reactant side. That's exactly what I want. So equation 2, we're not going to make any changes. We're just going to write it as H2 plus 1/2 O2 gives us H2O liquid, and there's no changes to that, so delta H would be negative 285.8. Okay, we also want to have 1 mole of C2H2 as a product. Equation 3 has 2 moles of C2H2 as reactants. So it's on the wrong side, and there's 2, we only need 1. So we're going to take the third equation, we're going to reverse it, which changes the sign of delta H, and then we're going to multiply it by 1/2. So we'll multiply delta H by 1/2 after we change the sign. So for equation 3, we're going to reverse it and multiply by 1/2. So the first product is CO2. That becomes a reactant, but we have to multiply it by 1/2. So 2 CO2. The second product, which will become a reactant, is H2O liquid. There's 2 of them. We have to multiply by 1/2. So that's H2O liquid. And then the 2C2H2 becomes C2H2 because we're multiplying by 1/2. and the 5 O2s becomes 5 halves O2. So now we're going to take negative 2598.8. Wow, that's a big number. Actually, that's one of the reasons that acetylene, which is a gas at room temperature, is used in torches for welding. It really releases an enormous amount of energy, 10 times as much energy per mole as the combustion of hydrogen in oxygen to form water. It's a lot of energy, okay? So we're going to change the sign, make it a positive, and we're going to divide it by 2, or multiply it by half. So you get positive 1299.4. And if we did everything right, we could add those delta H's, negative 787, negative 285.8, and positive 1299.4, and we'll get the correct delta H for the heat of formation of C2H2. Let's check to see. We're going to cancel anything that's on both sides. So there is 1 mole of water on both sides. There's 2 moles of CO2 on both sides. And then there's some oxygen on both sides. 2O2 is the same as 4 halves. 4 halves plus a half is 5 halves. 5 halves and 5 halves. We got it. That's everything. We've got 2C plus H2 goes to C2H2. Good problem because it puts together sample problem 5.7 and sample problem 5.8. So you're actually practicing both of them. So now we're going to add those 3 together. So we're going to take 787, which is negative. We're going to take 285.8, which is negative. And we're going to take 1299.4, which is positive. And we're going to get 226.6. And what you could do is you could go to Appendix 2 and look up the standard heat of formation of acetylene because it's in there. It's in the organic table, C2H2 gas, and you'll find that it is 226.6 or somewhere around there. It's pretty close to that. So this method does work. Okay.